Welcome. In this video, we are going to look into two fascinating features of AWS Rekognition, which are emotion detection and facial landmark detection. Have you ever wondered if a machine can understand how you're feeling just by analyzing your face? With AWS Rekognition, that's not only possible, it's surprisingly accurate. And in this video, we'll explore how it works, see it in action with a real-time demo, and discuss some powerful use cases where emotion recognition can make a real difference. And we'll also walk you through the pricing model so you know what to expect if you're looking to build this into your own applications. So, if you want to explore the possibilities of AI in human emotion analysis, this video will give you the foundation you need. So, let's get started. But before we move ahead, let's just understand what is AWS Rekognition, such as happy, sad, angry, surprised, disgusted, calm, confused, and fear. Each detected emotion also comes with a confidence score, so you know how likely it is that the person is actually expressing that emotion. But that's not all. Amazon Rekognition also supports facial landmark detection, which identifies key points on the face like eyes, nose, mouth, and more. This is incredibly useful for applications that require precise facial analysis. And if image quality matters to you, Rekognition can also analyze aspects like sharpness, brightness, and contrast, helping you automatically filter out low quality images before processing. So, whether you are developing a face-based app, enhancing user engagement with expression-aware features, or simply improving image analysis workflows, Rekognition gives you the tools to bring smart visual intelligence into your product. So, let's move ahead with the video to the next section, which is demo. Alright, so now let's just start with the most exciting part, our live demo. So now I'll just run the app and I'll open it in the browser. So this is the interface of the app. It's pretty simple and very intuitive, and we have also mentioned how it works. So first step is that you upload your media, be it an image or a video, and then you click on the select file button, and as soon as you do that, the processing starts by using Rekognition, and then you are able to view the results and export the data. Also, there are a few key features that you can find in this app, which is emotion analysis, then gender and age prediction as well, along with detection of facial attributes in the images and facial landmark detections. So let's see it in action. We are going to analyze both an image and a video using Amazon Rekognition to detect facial emotions, landmarks, and other facial attributes. So first up, I'll just load one image. Alright, so I'll start with this one and I'll click on Analyze Face Data. And now the processing has begun. Here we use DetectFaces API from Rekognition for this, and you can see that in this image 4 faces were detected, and this is the original input here, this image, and this is the processed one. Alright, so here we have drawn bounding boxes around the detected face, and along with the boxes we have mentioned the face ID by which Rekognition is indexing them, and the emotions that they are expressing the most. Alright, along with the confidence score as well. So let me just open this in a new tab so that we can view it better. Alright, so here you can see that these are happy faces, and it has been correctly identified as happy with 100% confidence, and in this case for phase 3 with 95.8% confidence that yeah, these are happy expressions on these faces, and here this one has been identified as calm. But this is not the only data that we can get through this. So let's just move here and see it in a little bit more detail. So for each of the faces that have been identified in the image, their gender has also been predicted, and here we can see that all of them have been predicted to be females, which is correct, right? And then their age range is also given in here. All of them are mostly in their mid 20s to late 20s, and that's also apparent in here. Like, we can get an idea that okay, this prediction is pretty much all right. And then these are the top emotions with the confidence level. But if I go and check on the details, let's say for face 1, so here face 1 is this one, all right, for this girl. So I'll click on details, and in this pop-up I'll get more finer details about the analysis. So for example, in here in the emotions tab, I can see that here, like, undoubtedly that face is happy, so there is no percentage of any other emotion that can be assumed in there, and that has been correctly identified in here as well. But if I go and check the attributes, then eyeglasses have been detected for face 1, and here we can verify that yeah, this person is wearing eyeglasses. And you can also see that it is differentiating between eyeglasses and sunglasses as well. So you can see how much finer these details are. And then it is also identifying that the eyes of the person are open, and there is a smile on the face, and the mouth is open as well. And all of it is true. Like, this can be verified. And then we have additional measurements as well, which gives some details about the head pose with different angles for roll, yaw, and pitch. And then we have face quality as well, that is the brightness of the face in the image along with the sharpness. And then we can also see the information about the landmarks. All right, so we have not seen the processed image for landmarks, but since we are here, let's just discuss this. So here it has identified facial landmarks for eyes, eyebrows, nose, and mouth, and other things as well, like pupils and jawline, etc. All right, and their dimensions have also been given for the identified points, which we'll see in the processed image for landmarks here. All right, so let me just open it so that we can get a better view. And this is the landmark detection here. So here you can see that it has identified upper jawline. It starts from here, then there is left pupil is there, this is the left eye, this is the right eye, the eyebrows have been detected as well, then the points for the nose, for the mouth and the chin. Like, they have been accurately detected in this image using Amazon Rekognition's DetectFaces API, right? So let's go ahead and see the stats tab as well. And here we have also provided the time it took for us to receive the data from Amazon Rekognition after processing this image. And to process this particular image, it only took 1.85 seconds. I mean, this is basically real-time processing that is happening in here for analyzing this image. And here we are also showing the image properties, or basically the image quality as well, which tells us about the resolution of the uploaded image, brightness and sharpness. And these details have also been fetched from the API that we are using. That is, we are not doing anything additional. The response that we are getting from Amazon Rekognition also contains the image property because we called for it while analyzing. So yeah, because we called for it in the backend while analyzing the image. So that's that. And then here we have the option to download the processed results for emotion detection and landmark detection and the CSV data as well. So like these two buttons are to download the processed images, and this is for this CSV data that we are showing in here. So let me just show the CSV file in here. So this is the CSV file. It gives us the top emotions and everything, and all the details that we have mentioned in the interface about the faces that have been detected. And now let's just check out one more image. I'll upload this one. It's processing the image. Let's just first take a look at the time it took. It took 1.72 seconds this time around to analyze the image. Now let's go here. I'll open this image and you can see that all of the faces have been detected in here. Even the one which is not fully visible. All right. And we can go and look at the data here as well. See, all those additional measurements are also there. So that's how it works for images. So it's not only limited to image analysis, we can also try out video analysis as well. So let's just go ahead with that. I'll upload one video. All right, and then I'll click on analyze face data. Now it takes a little bit more time to analyze a video as compared to an image. All right, so that would be reflected in here, and we use slightly different API for getting information about the video for the purpose of facial analysis. So the analysis for the video is complete. And here it is saying that 74 faces were detected, but it is taking into account the faces that are detected in each of the frames of the video and not the exact total count of the faces which are there in the video, although that can also be shown in here by keeping track of the index of the faces as well. So let's go ahead with this one. So this is the original video, which is 18 seconds long, and to process this 18-second long video, it took 102 seconds. That is, it took approximately 1 minute to process this video. And since we are here in this tab, so we can also see the image quality. So these are the properties of the frames that have been identified in the video. So this is the resolution, the brightness and the sharpness, and then we have video stats as well, which is, it is 18 seconds long and the frame rate is 30 frames per second, and faces detected was 74, which is not the actual count of the faces. It's basically a sum of the total number of faces it identified in each frame of the video it has analyzed. All right, so now let's go and check out the result. I'll open it in another tab. Let me just close the other ones. All right, this is a scene from a movie. All right, and here you can see that the emotion is being detected in real time. So here if I go back a little, then you can see how fast in real time the expression changes for this hero. It goes from calm to sad to angry, right? And these emotion detections are spot on in this video. All right, and the same way we can also show landmark detections as well. So let's just look into this too. And in this processed video also we can see the facial landmark points, and they are correctly being placed near the eye and the mouth and the nose. So it is being pretty accurate in here as well for landmark detection as well. Basically the facial landmark detections, right? You can see in here. Okay, so this is how face detection works with Amazon Rekognition for emotion detection and facial landmark detection. All right, we can also see the face data as well here for each of the face. And you could see in the video that with each frame, the count of the face was increasing. All right, because there we were not keeping track of the face ID in there. And so we have a list of 74 faces. And for all of them, the gender has been identified, the age range has been identified as well, and their top emotion as well. And you could see that it seamlessly identified the change in the emotion in real time. All right, so this is how it works. And obviously it just not only shows the emotions, but it also identifies attributes in there if there are any. All right, so as you could see here, for this particular face 0, it identified that the eyes are open, all right, but not the other attributes were there. All right, and then facial landmarks points are also there. So all of the data is being fetched from the API, and that too in almost 1 minute for an 18-second video, which is actually good. And even though this is video, Rekognition maintains high accuracy, making it a powerful tool for surveillance or user engagement analysis or any scenario where faces and expressions matter over time. And as the video plays, you can see how Rekognition keeps updating the data frame by frame, adjusting the expressions as they change, right? Like you can see here, like as soon as the expression is changing, it is reflecting the change in the response as well, right? And that's it for the demo. You just saw how easily you can extract rich emotional and facial data from both static and dynamic content with zero machine learning expertise required, because here we are just fetching the data from an API. So what we are essentially doing is we are providing the input to the API, then the input is being processed and the API gives us the output. That's it. It's as simple as that. So now that we have seen Amazon Rekognition in action for emotion and facial landmark detection, let's go ahead to the next section. Now let's talk about pricing, because while Rekognition is powerful, it's also important to understand the cost side of things. And the good news is you only pay for what you use. There's no upfront commitment and no minimum fee. Pricing is broken down into two main categories, which are image analysis and video analysis. So let's explore each. We'll start with the pricing for image-based analysis. So in the cases of image, for emotion detection, we use the DetectFaces API provided by AWS Rekognition, which falls under Group 2 in Amazon Rekognition image pricing. And here you are charged per image, and the pricing is tiered based on your monthly usage. So for the first 1 million images in a month, you are charged $0.001 per image. And for the subsequent 4 million images, you are charged $0.008 per image, and so on. As the volume of the images that you're processing in a month keeps increasing, the pricing keeps going down, as you can see in the table on the screen. So let's take an example to understand how the pricing structure works. So let's say your app processes 2.5 million images in a month for emotion detection, then the total cost would come out to be $2,200 per month. And you can see the calculation for it in here. So for example, in a month, if you are processing 2.5 million images, then for the first 1 million images, you will be charged $0.001. And for the subsequent images up to 4 million, you will be charged with $0.008 per image. So this is how the calculations for the prices work. And for landmark detection also, we are using the same API. So the pricing structure is the same as we discussed just now for both landmark detection and emotion detection. But here is something extra. If you use image properties for color brightness or sharpness analysis, there is a separate charge for that. So in case if you're only interested in getting image properties, then for the first 1 million images, you will be charged $0.0075 per image in a month. Alright, and for the next subsequent 4 million images, you will be charged $0.0006 per image, and so on. So this is only the pricing for the case when you are only interested in image properties. But let's say you want to use both emotion detection and image property together, then you'll just need to sum up the prices for these two use cases as shown in the screen. So if you're using both emotion detection or landmark detection with image properties, then for the first 1 million images in a month, you will need to pay $0.00175 and so on. So now let's take a look at the pricing for video analysis. So for video files stored in S3, AWS Rekognition charges per minute for emotion detection and landmark detection, and the rate is $0.10 per minute of the video. So If your app processes 100 minutes of video, then you will be charged $10 for it. And if you want to work with live video streams instead of stored videos, then the cost would drop to $0.00817 per minute, but you'll also need to account for other AWS services that you will need to use to be able to work with live video streams, and costs for them would be added separately. There is also AWS free tier. AWS offers a free tier for the first 12 months after account creation. And with that, it gives you 1,000 images per month free for emotion and facial landmark detection. But it should be noted that image properties and videos are not included in the free tier. So you can start experimenting without worrying about costs. It is perfect for developers or startups testing out features. So now that we have covered the basics of how AWS Rekognition works and its pricing, now let's move into some real-world use cases. These features have huge potential across various industries, providing valuable insights and enhancing user experiences. We'll first start with emotion detection use cases. So, the first use case for emotion detection can be customer experience and feedback analysis. Emotion detection can play a crucial role in analyzing customer feedback during calls or in-store visits. Imagine a retail store that wants to gauge how customers feel about their shopping experience by analyzing video footage or even images. Rekognition can detect emotions like happiness, frustration, or surprise. This can help businesses improve customer service or tweak marketing strategies to evoke positive reactions. It can also find use in market research and advertising. In the marketing world, it's all about understanding consumer emotions to design better ads. By analyzing how viewers react to different advertisements, companies can optimize their campaigns for maximum emotional impact, whether it's joy, excitement, or even anger. Knowing these emotions helps tailor content to resonate better with the target audience. Another use case for emotion detection can be seen in health and well-being applications. For healthcare applications, emotion detection can be used to assess patients' mental states, especially in remote healthcare services or therapeutic sessions. This technology can help therapists monitor patients' well-being and detect signs of depression or anxiety, providing timely interventions. It can also find use in gaming and entertainment. In the world of gaming and entertainment, emotion detection can be used to tailor in-game experiences. Imagine a game that adjusts its difficulty based on the player's emotional responses, keeping them engaged and entertained. It's all about creating a more personalized and immersive experience. Now, let's move ahead to discuss the use cases for facial landmark detection. For this, the first use case can be enhanced facial recognition. Facial landmark detection significantly enhances facial recognition systems by pinpointing key points on a face such as the eyes, nose, and mouth. This allows for more accurate identity verification in secure environments like banks, airports, or high security buildings. By analyzing these facial features, Rekognition can ensure a higher level of precision in detecting and identifying individuals. Another use case can be in augmented reality experiences. In AR applications, facial landmark detection is used to overlay virtual elements on a user's face. For example, AR filters on social media platforms use these landmarks to apply makeup or other fun effects like animated eyes, sunglasses, or even virtual masks. By identifying key points on the face, Rekognition helps make the experience more realistic and engaging. It can also be used in virtual try-ons in retail. Facial landmark detection is also being applied in the retail industry for virtual try-ons. For instance, beauty brands use Rekognition to allow users to virtually try on makeup products, see how different glasses would look on their faces, or even test out hairstyle options. The technology uses key facial features to ensure that the virtual products align correctly with the user's face. Another use case can be seen in facial surgery and beauty analysis. For medical applications like facial surgeries, facial landmark detection can help analyze changes in facial features. Plastic surgeons can use this technology for before and after comparisons or even for planning surgeries. Similarly, in the beauty industry, Rekognition can help individuals analyze their facial features and determine how certain cosmetic changes might affect their experience. So, as we have just seen, AWS Rekognition offers powerful capabilities that can transform the way you interact with images, videos, and even emotions. So, whether you are looking to enhance user experience, gain deeper insights into customer reactions, or build advanced applications, emotion detection and facial landmark detection are tools that can take your projects to the next level. But implementing these technologies might seem overwhelming, especially if you're just getting started or want a personalized solution tailored to your specific needs. That's where Codersarts comes in. We specialize in delivering custom solutions using AWS Rekognition, ensuring you get the most out of its features, whether it's emotion detection or facial landmark analysis. So, if you're looking to integrate these powerful tools into your application or need expert guidance to optimize your project, we are here to help. You can reach out to us today. Our contact details are visible on the screen, and you can find our social media handles in the description box down below. And if you found this video helpful, don't forget to like, subscribe, and turn on notification so you don't miss out our upcoming videos. Thank you.